welcome you all in the presentation of Irrigation Engineering Subject Module 4, Regulating and Cross Drainage Works. I am Trupti Pandya from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. So in this video, we will start with canal regulating works, and then in part 2 we will discuss about cross drainage works. So let's start with the canal regulation works. So first of all, what is canal? So an artificial waterway constructed to allow the passage of boats or ships or to convey water for irrigation provided with permissible slope. So canal is an artificial waterway which is used in India mainly for irrigation purpose, and in other country it is used for water transportation. So it provide waterway, right? Now regulating work or regulation works. Canal regulation works are these structures constructed on a canal to regulate the discharge, full supply level, or velocity of flow are known as canal regulation works. So in canal, water flow through gravity by providing bed slope. So to regulate the flow, right, the level and the velocity, some hydraulic structures are constructed, right, and that structures which control or which regulate these three things of flow are known as canal regulation works. These structures are necessary for efficient functioning of an irrigation canal system. The various regulation works are canal falls, canal escapes, cross regulator, and distributary head regulator. These are the structures which are to be constructed on canal to regulate the flow or velocity or the level of water. So let's start with canal fall, the first regulating structure. A canal fall is an irrigation structure constructed across a canal to lower down its water level and destroy the surplus energy liberated from the falling water which may otherwise scour the bed of canal. So canal fall is constructed to regulate the water level, right? Canals are constructed with some permissible bed slope so that there is no silting in the canal bed, right? Ground surface may be steep and sometimes it may be very irregular with abrupt change of grade, right? So at some location the ground level and the canal bed level are not matched with each other. So at that condition, to level the both levels, canal fall is constructed. Here is the point: when the slope of ground suddenly changes to steeper slope, the permissible bed slope cannot be maintained. It requires excessive earthwork in filling to maintain the slope. In such a case, falls are provided to avoid excessive earthwork in filling. Here is the figure. So in case of road construction work, same case may arise that the road alignment and the ground level did not match. So to match the levels, we are using earthwork of cutting and filling. But in case of canal, that cutting, filling or the earthwork quantity is very large, which is not economical. So to maintain the level, or we can say to maintain the water level, a structure is provided instead of filling with earthwork to match the bed level of canal and the ground level. We are constructing canal fall. So in this figure we can see that the ground surface on higher level and the canal bed on lower level. So to for, or we can say, for smooth flow of water, we construct canal fall. So this line diagram show the structure line which balance, or we can say which connect the ground surface and canal bed, and thereby it provide smooth flow of water. When the slope of ground is more or less uniform and the slope is greater than the permissible bed slope of canal. So this is second case. First case, the ground slope is very steep, and this is the second case, that the slope may be more or less uniform or greater than the permissible canal bed slope. At that time also we can construct canal fall for smooth flow of water. The third case, in CD works, or we can say cross drainage works, when the difference between the bed level of canal and that of drainage is small, or when the FSL of the canal is above the bed level of drainage, then the canal fall is necessary to carry the canal water below the stream or drainage. In this figure we can easily identify that at the location of CD works, the that concrete floor which support the CD work at lower level and the ground level at upstream, or we can say downstream side, at higher level. So for smooth flow of water, to avoid the hydraulic jump, we can provide at the upstream side canal fall, right? So clear? The fall is a structure, hydraulic structure, which is constructed across a canal where the ground level and the canal bed level are not at same RL, right? So instead of filling the earthwork, we can construct fall for smooth flow of water, right? So there are many types of falls are constructed according to level difference and according to situation. So these are the types of fall: augie fall, rapid fall, trapezoidal fall, stepped fall, Montague fall, vertical drop fall, straight glacis fall, English or buffalo fall. So these are the known type of falls which are constructed everywhere, but at some location, but at some location uh, there are some changes in structural design, and at that change type of fall may be provided with some other name, like Sarda type fall, which was constructed on Ganga Canal, right? So there are many structural design specified type of falls are there, but these are the known well fall, right, which are listed out over here. Let's see one by one. So these are the consideration while selecting the type of fall, the height of fall of water, the discharge passing over the fall, topography of site location, type of soil in upstream and downstream of structure, and economy. So, while selecting the types of fall which are listed in previous slide, these are the factors are affected. Augie fall. It is an augie curve. Augie curve is a combination of convex curve and concave curve. Is provided for carrying the canal water from higher level to lower level. This is the typical cross section of augie fall. So this shape is known as augie shape, right? So this is typical cross section of augie fall. It is one type of weir, but this is the upstream bed level of canal and this is downstream bed level of canal. So to match this difference, we provide a smooth flow of water so that the water can flow very easily and the velocity of flow can be maintained properly. So for this we have to construct a concrete bed below and on which maybe stone masonry pitching or rubble masonry or combined, or we can use masonry work only, or we can use concrete work only for construction of this structure. So this structure is known as augie fall, which is constructed across a canal bed. Right now, for the protection of this concrete floor, uh, stone pitching is done at the downstream end and the concrete floor is little length extended at the upstream side, right? So this is the typical cross section of augie fall. It is limited to lower depth. This is actual figure. Due to smooth transition, velocity of flow is not reduced since it may cause erosion in downstream. It has high discharge efficiency. It is nothing but the smooth curve, smooth passage. So the velocity difference is very less at upstream and downstream of that particular structure. So in case of augie fall, the downstream bed may erode and the discharge we cannot control much, so the discharge is good, efficient discharge. Rapid fall, right? Rapid fall, it is suitable when the slope of the natural ground surface is even and long. It consists of a gentle longitudinal slope which vary from 1 in 10 to 1 in 20. So here, in case of rapid fall, the distance of this bed level is more. This is the upstream phase and say this is downstream phase and this distance is more. So in this case, the augie fall is not suitable, right? For that, for smooth passage or to smoothening the slope, rapid fall is constructed, right? So step by step with 1 in 10 to 1 in 20 gentle slope, rubble masonry is done for smoothening or to mesh the level, and for the protection of that rubble masonry, the curtain walls or we can say pile or we can say cutoffs of concrete are provided for stability of this rubble masonry, right? So this is rapid fall which is suitable when the natural ground surface is even and long with the slope of 1 in 10 to 1 in 20. Rapid fall, They are expensive compared to others and commonly used at West Yamuna Canal. This is actual figure of rapid fall. Trapezoidal fall. In this, the body wall consists of some trapezoidal notches between the side piers and the intermediate piers. The seals of the notches are kept at upstream bed level of the canal. So this is typical cross section of trapezoidal fall, right? It may of singular or number of openings constructed at high crested wall, providing smooth entrance to the downstream. With this, the depth of discharge value are less affected. These are quite common and economical. So trapezoidal fall is economical compared to previous two falls. Stepped fall. It consists of series of vertical drops in the form of steps. As you can see in the figure, that the slope or the difference of level is managed by providing the steps. This figure is more clear. See, this is step fall. This kind of fall is suitable in places where sloping ground is very long and require a long gentle slope to connect the higher bed level at upstream side with lower bed level at the downstream side. So where the slope difference or the level difference of upstream and downstream bed level is very high, at that location steps are provided for smooth passage of water. Step flow. Vertical drop fall. In this type of fall, the canal upstream bed is on the level of upstream curtain wall. Canal upstream bed level is below the crest of curtain wall. In both the cases, a cistern is formed to act as water cushion. See, where the slope difference is less or the level difference is less, so we can smoothly for smooth flow of water we can construct the vertical wall like this is vertical drop wall, right? So in this case the water directly fall on this concrete floor, which may erode, this falling water may erode the bed, or we can say concrete floor. So to eliminate this effect, a curtain here the wall is provided. So this create a box type structure. So the first falling water is stored over here by this wall, right? And the next water falling on the water only. So thereby the first falling water provide water cushion to the next, and thereby we can reduce the erosion or impact of falling water on bed or concrete floor, right? So in case of vertical drop fall, a water cushion is created by cistern. This is the vertical drop fall sketch. It is easy to construct and it is economical. Losses may be high in case of higher height or depth. For discharge up to 15 cumax, vertical drop fall is used. Straight glacis fall. This is the typical cross section of glacis fall. It consists of straight glacis provided with a crest wall. For dissipation of energy of falling water, a water cushion is provided. This is the actual figure of straight glacis fall. In general, slope provided in this kind of fall is 2 1. This kind of fall have a good performance. This kind of fall is suitable for a flow of up to 60 cubics and a drop of about 1.5 meter. So this is the typical section of straight glacis fall, in which a weir wall is constructed. Okay, this whole structure is of concrete. The height of that crest wall is high. Here the upstream bed level and this is downstream bed level, and the distance and difference is very high. So this whole structure, this whole concreting work is known as glacis. Now, sloping, pitching and profile wall are the protection work, downstream protection works, which protect the glacis floor from say erosion or scour, seepage, etc. Right, so this is glacis fall. This is its view. Now, Montague type fall. This is the figure of Montague type fall. In this straight, steep type profile, energy dissipation is not complete. Therefore, Montague developed this type of profile where energy dissipation take place. Right, so this is special type of parabolic glacis. I already told you that glacis are nothing but the concrete flooring work, right? So here the parabolic shape of that concrete bed provide smooth disposal of water from that fall location. English or buffalo fall. Here glacis is straight and sloping, but the buffalo wall provide on the downstream floor dissipate the energy. Main body of glacis is made of concrete. Curtain walls both at toe and heel are provided. Stone pitching are essential both at upstream and downstream side. So here again the fall is of straight slope of concrete, but that falling water energy dissipated by buffalo walls are the nothing but the blocks, concrete blocks provided at the downstream end. So this is completely this topic of canal fall. Let's start with canal escape. It is a side channel constructed to remove surplus water from an irrigation channel, whether it is main canal or branch canal or distributary, etc., into natural drain. So it removes the excess water from main canal to natural drain, we can say. The water in the irrigation channel may become surplus due to mistake, difficulty in regulation at the head, excessive rainfall in the upper reaches, outlets being closed by cultivators as they find the demand of water is over. So these are the reasons due to which the channel, or we can say canal, may get excess water. It is the structure required to dispose of surplus or excess water from the canal from time to time. Thus, a canal escape serves as a safety valve for canal system. It provides protection to the canal from possible damage due to excess supply, which may be due to mistake in releasing water at head regulator or heavy rainfall that makes sudden regulator demand of water. The excess supply make the canal banks vulnerable to failure due to overtopping or dangerous leaks. Therefore, provision for disposing this surplus water in form of canal escape at suitable interval along the canal is essential. Moreover, emptying canal for repair and maintenance and removal of sediment deposited in the canal can also be achieved with the help of canal escape. So these are the, we can say, function or purpose of canal escape. The main function is to remove the excess or the surplus water, so thereby we can protect the surrounding land around the canal, right? If we cannot dispose the excess water into the surrounding lands, so by providing escape canal, the main canal can be protected from overtopping, right? Type of canal escapes. Escapes are usually of three types. Surplus escape first. It is also called regulator type. In this type, sill of the escape is kept at canal bed level and the flow is controlled by a gate. These type of escapes are preferred nowadays as they give better control and can be used for employing the canal for maintenance. So for maintenance purpose, if we want to emptying the canal, the main canal water can be disposed or transferred into the surplus escape canal. So this is the typical cross section of surplus escape canal bed with apron and gates. So second figure is the surplus water escape with gates. Tail escape. A tail escape is provided at the tail end of the canal, so at the end of canal, and is useful in maintaining the required FSL full supply level in the tail reaches of the canal and hence are called tail escape. So specially it is constructed to maintain the FSL at the end of canal system. So again that water level is raised by that weir wall of required height, and then after the water is released by gates. Third is scouring escape. This escape is constructed for the purpose of scouring of excess silt deposited in the head reaches from time to time. Hence, it is hence it is called scouring escape. So, tail escape is constructed at the tail end of the canal, while scouring escapes are constructed at the head reach. Here, the sill of the regulator is kept at about 0.3 meter below the canal bed level at escape site. When deposited silt to be scoured, a higher discharge than the FSL is allowed to enter the canal from the head works. The gate of the escape is raised so as to provide scouring velocity which remove the deposited silt. This is the bed view of scouring escape. This type of escape has become obsolete as silt ejector provided in the canal can produce better efficiency. Next canal regulating structure is head regulator. Head regulators constructed at the off-taking point are called head regulator. When it is constructed at the head of main canal, it is known as canal head regulator. And when it is constructed at the head of distributary, it is called distributary head regulator. So head means at the starting point of off-taking canal. Function. The functions of head regulators are: first, to control the entry of water either from the reservoir or from the main canal. So it is one type of gates which control the entry of from the canal or from the reservoir to the off-taking canal or distributary canal. To control the entry of silt into off-taking or main canal. Second function, it controls the silt entry. To serve as a meter for measuring discharge of water. At that location, we can measure the flow or we can measure the discharge of water into the canal. Construction. The component of head regulator depends upon the size of canal and location of head regulator. It consists of one or more gated research opening with barrels running through the banks. For large canals, head regulators are flumed to facilitate the measurement of discharge. So depending upon the location, the function or the type of canal, the construction of head regulator differs. So this is one type of canal head regulator with piers and abutment and with gates. 4 gated head regulator over which the road is constructed. This is the typical cross section of head regulator with concreting work and mechanism of gates. Cross regulator. A regulator constructed in the main canal or parent canal downstream of an off-taking canal is called cross regulator. It is generally constructed at a distance of 9 to 12 km along the main canal and 6 to 10 km along the branch canal. So this is we can say a typical distance at which the cross regulators are constructed. Functions: to control the flow of water into the canal system, to feed the off-taking canal, to enable closing of canal branches on the downstream, to provide roadway for vehicular traffic. Almost the functions of head regulator and cross regulators are same, but the location is different. Construction. For cross regulators, abutments with grooves and piers are constructed parallel to the parent canals. The sail of regulation is kept a little higher than the upstream bed of the canal across which it is constructed. Vertical lift gates are fitted in the grooves and the gates can be operated from the roads. So it is nothing but the gated structure, right? Head regulator and cross regulator. So this is the say typical sketch of head regulator and cross regulator. So on parent canal, cross regulator is constructed. On off-taking canal, head regulator is constructed. And the pattern of crossing of canal is shown, right? So depend on that whether it is main canal or distributary or parent canal, the cross regulators are constructed, right? So gated structure, which both are gated structure and the functions of both are them, but one is constructed on parent canal, another is constructed on off-taking canal. Yes, this is say top view. So piers and gates are shown and the ends are known as abutment, but from main canal cross regulator and from off-taking canal or distributary height regulators are there. Okay, this is the cross section. We show the levels and concrete floor and piers and gates of cross regulator. Right. So in next video we will see about silt control device.